Hello, this is Britt Caswell with another example video. In this video, I'm zooming apparently. Sorry about that. In this video, I'm covering section 2-6, example number 2, in the SavvasRealize Algebra 2 textbook. We're going to be looking at how to choose a solution method. So how to choose how to solve a quadratic. So remember, there's 4 ways in which we could solve quadratics. There's factoring, there's graphing, there's completing the square, and then there's the quadratic formula. So those are the 4 things we can choose from. So I almost never choose graphing as a method to solve. And the reason why is that, well, there's actually 2 reasons. One, you can't always tell exactly where the parabola crosses the x-axis. It's only in a few cases is it at a whole number. The other reason is, what if you have a parabola like this with imaginary solutions? You can't tell any of the imaginary solutions based on a graph. So I almost never use graphing. I'll be honest there. I'm just like, ain't nobody got time for that. Now, graphing is useful for many things. It's useful to help you understand, the context of the problem. So I graph things pretty regularly, but I don't use it to find the solutions. Completing the square can be really easy, especially if you're using my template method that I've shown you guys. But if you have a number that's odd here in the middle, that like having that odd number makes it really hard, because then you have fractions and it's kind of ugly. So on this one, I definitely wouldn't use completing the square. So then I'm going to solve it with factoring just to show you what a nightmare it is to solve by factoring. But let's be honest, think about this. When we go to factor it, right? We do take the 6 and we multiply it to the 20. That's 120, and we have to find the factors of 120 that subtract to make 7, and that's kind of, it's doable. It's just a pain in the butt. Alright, so now that I've complained about it, let's go ahead and solve it out. So I was talking about factoring, so I'm just going to go ahead and do that first. Remember, in this book, we cover factoring by grouping. So I'm breaking apart this minus 7x into 2 terms that are going to be separated by a plus. Okay, everything else stays the same. We'll still have a 6x squared. We'll still have a minus 20 and an equal 0. Recall, with any of these methods, really, you need your equation equal to 0. So if you do not have your equation in standard form equal to 0, you need to check yourself. Alrighty, so again, I'm taking my a times my c. It's technically 120, but I'm just going to, or negative 120, but I'm just going to call it 120. And so what I'm doing is I'm enabling myself to ignore the signs when I'm doing this, because with that negative number, right, I could have like negative 1 times 120 or 1 times negative 120. And it really just doubles my list, and that's a bit of a nightmare. Okay, so with my method, I just multiply them to get the base number, and then this second sign here tells me whether I need to add or subtract. So I'm going to be subtracting my factors until I get one that subtracts to make 7 here. Well, I have 1 and 120. So if I subtract that, that's 119. I have 2 and 60. Okay. So I'm not anywhere near yet, right? 3 and 40. That's 37. 4 and 30. That's 26. 5 and, I actually know this one off the top of my head. 24. That subtracts to make 19. I have 6 and 20. We're getting closer. It's not divisible by 7. It is divisible by 8. It's 8 and 15. And 15 minus 8 is 7. Oh, thank goodness. There it is. So, when those numbers get really big, this factoring list gets really long. And notice I just systematically went through 1, 2, 3, 4, 5 until I start getting things that meet. So I know I'm going to have 8 and 15. Now in order to get 120, or I'm sorry, I know I'm going to have opposite signs, right? Because I have a negative here, really, it's negative 120. So one of these will be positive and one will be negative. Now in order to make it a negative 7, that means that my 15 has to be the negative one because it's the bigger number. Alright, so now with factoring by grouping, right, we put them in parentheses, making sure to put the plus between them. And then we factor out our GCFs, our greatest common factor. So here, my greatest common factor is 3x, because 3 goes into both 6 and 15. If I divide that out, 3x divided from the 6x squared is 2x. And negative 15x divided by 3x is negative 5. Then we do the same thing here. I believe it's a 4. So then we divide each of these terms by 4. So 8x divided by 4 is 2x. And negative 20 divided by 4 is negative 5. Remember, our goal is to have this matching set of parentheses because that's what falls down as one of our factors. And then the stuff that we factored out turns into its own thing. And then to solve, we set each equation equal to 0, right? So I have 3x plus 4 equals 0, which I then subtract the 4, and then divide by 3. And then with this one, the 2x minus 5. So here, I mean, while I'm solving this out, you can see the factoring by grouping had a lot to it, didn't it? So like, I would not have originally chosen factoring by grouping just because this was such a big number that I had to go through a lot of work to find my factors right away. But if this had been an expression that was easily factored, then I would have chosen my factoring option. So now we're going to do it with the quadratic formula. Now a lot of people tend to dread the quadratic formula because it's long. But you know what? Sometimes the other methods are long too, so don't be intimidated by the quadratic formula. Alright, so I fill in my b terms. I have negative 7. I fill in my a terms. I get a 6. And I fill in my c term and I get a negative 20. Now these numbers are big, they're kind of but they're also things you can kind of manage, right? So like I'm not hunting down factors yet, I'm just kind of pulling stuff apart. So I'm simplifying this discriminant here, so negative 7 squared is 49. I have a minus and a minus, so I know this is going to be a plus. 4 times 6 is 24 times 20. Just making sure I'm not goofing. It's 480. So if I add those, I get 529 inside my radical. Ugh. Now if I could do that factor tree, I really have to work for it, don't I? I'm going to be trying some odds, a couple of things that I think might be there. Didn't work with 3, 7, 9, or 11. Didn't work with 17 or 15. So this one's kind of hard. And so, you know, with this, you just kind of have to keep plugging in numbers over and over and over and over and over again, just to try to figure it out. Here, you know, I know it has to have some kind of odd because it ends in an odd. So I'm just doing all my odd numbers. There we go. So I finally got up to 23. Okay, so 529 divided by 23 is 23. So that was a perfect square. You could have just plugged in the square root of 529 and seen that it was 23. But I'm so used to it not being a perfect square that I didn't even think about that. Well, so the square root of 529 is 23. So that's going to be nice when we go to simplify. So here we are. So I have plus or minus, or sorry, minus 7 makes it a plus 7. Plus or minus that 23 that I had to go through so much effort to get. And then down here, 2 times 6 is 12. Now in my example videos for quadratic formula earlier, I used to leave the 2 and the 6 separate, right? I didn't do that here because these are both odd. It made no sense. Alright, so now the 7 and the 23 are like terms. So they can actually be combined. So I'm going to split this into two equations where I'm combining them. So I have x equals 7 plus 23 over 12 and x equals 7 minus 23 over 12. So here, 7 and 23 make 30. And 30 and 12, those are both divisible by 6. So this reduces to 5 halves, which is what we got in our first step. Now here, 7 minus 23, that's negative 16 over 12. And so those are both divisible by 4. So that gives me negative 4/3, which is my first answer. So depending on your type of thinking, you know, if I had just plugged in the dang square root to see if it was a perfect square, this probably would have been easier. But some people find factoring to be easier depending on the problem. Okay. So on this one, I'm going to do factoring again because completing the square would really be terrible here. Graphing would really be terrible here. But let's try factoring and let's see if we can, I don't know, puzzle this out. Who knows? I mean, I don't even know off the top of my head if this is even factorable, right? So when you when you're doing factoring, if you're not used to looking to seeing if they're factorable or not, it's kind of taking a shot in the dark, right? So I'm going to try factoring by grouping, and it could be completely wrong. It could be nothing useful. Alright, so a times c, I'm doing 6 times 15. Alright, that's 90. And then my b value here is 1, and they have to subtract. So I'm finding the factors of 90 that when I subtract make 1. Well, 90, that's divisible by 10, and so 9 and 10 I think is the quickest one to see. So that was pretty easy. Now because this is a positive 1, and I know I need opposite signs to get the minus 15, I'm going to keep my 10 as the positive one because it's the bigger number. So I'm going to say plus 10x plus negative 9x. And I know it's weird to put that plus and then the minus right away, but remember when you put the parentheses, you have to have a plus between it. So now I factor out my GCF. So between 6x squared and 10x, that sounds like a 2x. So 6x squared divided by 2x is 3x. And 10x divided by 2x is 5. So I know that this second set of parentheses has to look like 3x plus 5, right? Because we need them to match. So when I'm figuring out what I'm factoring out here, do you see how my signs are different? That means I need to factor out a negative. And then to go from 9 to 3, it's going to be dividing by 3. So here I have 2x minus 3. And I have 3x plus 5. And I'm going to be setting each of those factors equal to 0, right? So the 2x minus 3 equals 0. I add my 3, and I divide by 2. And then for my other one, my 3x plus 5 equals 0. I subtract my 5. I divide by 3. Alright, so there it is with factoring by grouping. It wasn't terribly difficult because I found my factor right away, but it had a lot of steps to it. So now I'm going to use my quadratic formula and see if it's any better. Oops, forgot my 4. Come on, Miss C, get your life together. Now I feel for you guys because this is kind of a long video, but I'm hoping that it's helping you to see, you know, that you can use whatever method you want. It's just what you're more comfortable with, right? If I was really comfortable with completing the square, I could complete the square on these. I mean, that odd number though gives us those fractions, and that's just such a bear because people get really uncomfortable with fractions. So I'm pulling down my discriminant. So 1 squared is 1. Negative and a negative makes it a positive. 4 times 6 is 24. So 24 times 15 is 360. So that's 361. And I ain't no fool. I'm going to check to see if this is a perfect square first before I go about all that factoring issue stuff. Fool me once, you know what I'm saying? Oh, thank goodness it is. It's 19. So the square root of 361 is 19. Say so. I guess if we had just plugged the dang thing in, it can get pretty easy. Now, am I always going to have a perfect square? No. That's only when my answer is a whole number answer. Alright, so now this is where we're splitting it into two equations because the 1 and the 19 are like terms, okay? So here we go. So I have x equals negative 1 plus 19 over 12. And I have x equals negative 1 minus 19 over 12. So here, this is 18 over 12, and those are both divisible by 6. So there's our 3 halves. Here I have a negative 20 over 12. Those are both divisible by 4, which would give me negative 5/3. So on this, it was about as much work for both of them, although having this be a perfect square for my discriminant was really nice. Alrighty, so that is picking a method. Until next time.